Going. So this morning I'm going to be bringing you the presentation from the comfort of Visual Studio Code. Both Pete and I have been doing software development so long we've forgotten really how PowerPoint works, so we're more comfortable working in notebooks. First, you might be asking, what is MSTICPy and what has it got to do with notebooks? And this is the fourth, I think, in the series of notebooks in Sentinel sessions that we've done. And MSTICPy is the Python library that powers most of the notebooks in Sentinel. Kind of automates a lot of the stuff, and we'll look at examples of its use later in the presentation. So this is what we're going to be talking about. We're going to have a bit of a recap, particularly for people who may not be familiar with notebooks or MSTICPy, bit of an overview, and then walk through some of the features. We just had a month or so ago released a major update to MSTICPy, a lot of changes, new features, different ways of using it. So we're going to be looking at some of those new features and some of the new ways we can use it. So we have fairly well crafted, I guess that's an opinion left to you, but we spend a fair amount of time writing documentation. So we have got a document that covers the release v2 and some of the features in it. We also have a companion notebook, which is a version of what we're going to be presenting today, so you can take it and experiment on the new features yourself. So a quick recap about MSTICPy, particularly for people who may not know what it is. So it's an open source library. It's free. It's a library for InfoSec investigation and hunting, primarily in Jupyter notebooks, so that you can also use it in Python apps and scripts. There are a few different feature areas. So the first one is like querying log data from multiple sources, obviously from Azure Sentinel, but also Azure Sentinel as was, Microsoft Sentinel, Microsoft Defender, and also other things like Splunk, Sumo Logic, other SIEM tools. We have a bunch of transformations and analysis, such as extracting IOCs, doing decoding, a bunch of enrichment features, so getting threat intelligence about IP addresses and URLs, getting Azure data about Azure resources, and finally a whole set of visualizations, so things like timelines, process trees, and we'll see some examples of some of these in the presentation. And there are also a bunch of time-saving widgets and things like that to automate the use in notebooks. So let's have a quick recap at a couple of features. So we always start pressed the wrong key. With these two statements, so importing MSTICPy and then running this init notebook function, and these two together kind of initialize the environment, import a bunch of things to get ready for use of the library and use of the notebook. So here we're going to be importing some data using a query provider, and this is similar to the way you would query data from Sentinel or any other source. In this case, we're just using local data, so querying from a local CSV or a pickled file. So we're just going to import and get the data frame, and here we've saved it as processes df. And this is kind of what it looks like, just a list of Windows processes. Examples of some of the kind of processing we can do on it. Second, we're going to extract any command lines for these processes that appear to be base64 encoded, and then try to decode them. So in the same thing. So this is extracting any base64 decoding. And you can see in some cases, things look a bit like they could be base64, but really aren't. But there are a whole bunch of command lines that are encrypted. And over here, we can see the the results of decoding. Sorry, not encrypted, encoded. So quick example, number 1. Number 2, to show you some of the visualization stuff, we're doing a little bit of tidying up here. So we're rejoining the first statement, rejoining this decoded data set that we just extracted from the process data, rejoining it back to the original data, so we can still see the process name and stuff like that. And then we're splitting out process names, so we're just going to get the exe part, the sort of the file name of the process. And then we're going to plot a timeline. So we can then see by each process, we can see when it happened in relation to the others, and we can see here 4 processes that have happened at the same time. And in each case, it gives us the decoded string for the process. Okay, so that's a bit of a recap of an example bit of usage in MSTICPy. Let's look at the state of the nation. So it's approaching its 4th birthday. I think it was started in September or October 2019, with a grand total of about 7,500 lines of code, and mostly not very good code, because I was quite new to Python coding at that time. We've had a big change since then. It's now like over 200,000 lines of code. A lot of that changed in version 2, net new kind of 30,000 lines of code. Some odd facts which are not very relevant to anybody but us, but our most active month, we had 35 PRs last December when we did a coding hackathon. Excuse me. And oddly enough, our most active hour of the week, for some reason, we do twice as more check-ins at 2 p.m. Pacific time on Tuesdays than we do any other time of the week, and we have no idea why that should be. We recently passed 1,000 GitHub stars, and this is, for me, it's sort of a really nice thing, because it means not only are people downloading it, but they're kind of engaged with the code. They're curious enough to go to the GitHub repo, look at the code, and like it. So if any of you out there that haven't done that, I've conveniently put the URL of our repo. If you think the code is good, please give it a GitHub star. Excuse me, I'm croaking a bit this morning. I'll try and press on. We also recently passed 145,000 downloads. And as I said before, it powers most of the notebooks in Microsoft Sentinel. It's interesting to see a geographic distribution, and these are the people who've starred the repo. So it's not necessarily people who are using it, but people who've using it, have liked it, have come back to the repo. We're a bit US centric in that some third of our starers are based in the US, but other than that, a fairly broad distribution. Sort of China, India, Australia, the UK. For some reason, people in Canada don't seem to like it. I don't know if Canada features on there much at all, but we've got a reasonably good coverage over large parts of the world, which is very pleasing, given especially we are it's open source, so we do our own documentation. We don't really have the Microsoft Docs auto translation, so our documentation is only in English, so it's especially pleasing that as many non-English speaking parts of the world are using it. Okay, so project reorganization. So MSTICPy has evolved over these 4 years in a bit of a haphazard way. I mean, we do design things, but as we've added new features, we've kind of put them where they seem to make sense at the time. And looking back, things didn't end up always in the best place or in a very logical way to be able to find them and to use them as a user. So we've done a lot of reorganization. So it may be that some things that you used to be in one place are now somewhere different. To help that a little bit, we've built this simple search feature. All it does is search for substrings of module names. So if you're looking for Sentinel or something like, let's think, threat intelligence, something like that. And these, it will give you the thing that you need to import, and also a link to hoping this works. There's a lot of stuff happening there. Just Synapse Analytics. Anyway, that link, there's a lot of stuff opening on my desktop, but oh, there we go. A link to the documentation, at least in this case, the API documentation, which may not be exactly what you were looking for, but you can then navigate through the documentation and perhaps find the thing you wanted. Okay. So we've got a section later on that talks a bit more, if we have time, it talks a little bit more and gives a table of like where things used to be, where things are now. And in most cases, if you have an existing notebook, the imports from the old place still work. We put kind of glue code to let that still work, but it's useful to be able to know exactly where things are, and we hope it's a more sort of sensible layout. So one of the things we were trying to do in release 2 was to simplify imports. Why are 7 cells hidden there? Okay, unhide them. So, as I said before, our opening initialization lines are always these two things: import MSTICPy as MP. We've adopted this like house style. If any of you are familiar with using Pandas or NumPy, you typically import Pandas as PD and NumPy as NP. We thought it might make it easier to do something similar. So this is entirely optional. You could just say import MSTICPy and use MSTICPy here. But this really initializes, imports MSTICPy, runs some initialization functions. The first thing to note is we have a lot more things that are directly accessible from MP. So things like query provider, TI lookup, a lot of our classes are just sub-attributes of the MSTICPy top level thing. So you don't have to search for and import them, they're already kind of there. As a simple example, check version. I should have cleared all the outputs because I'm spoiling the surprise. Check version. Just tells you what's installed. It's just an example of a simple function. The search was also a thing that's available from top level MSTICPy. Running the init notebook also imports a whole bunch of stuff into the notebook environment. So having run that, we can see this is not kind of a complete list, but I was trying to craft some kind of query where I could query the notebook locals variables for things that had a module that had MSTICPy in them. So you can see here we're importing things like Folium map, various types of entities, and a few different functions. So what does that give you? Well, it means you can start to do things without having to remember where to import something from. So one of the entities that's imported is IP address. So it means we can start to run with IP address here, and we can start to run functions like methods of the IP address without having to worry where to import it from. It's just available in the notebook. Here's another example where we can get the geolocation. We don't have to do any more initialization. It's just there. So another thing we've tried to do to make life a little bit easier and to have less thinking about where something is in the library and the structure of the code, and more thinking about threat hunting, the investigation part of it, is we've exploited more Pandas accessors. So Pandas accessors, that sounds a bit of an odd term. What is that? So Pandas, the thing we use like like this thing is a Pandas data frame, and we use Pandas data frames pretty much universally throughout MSTICPy to store data that's retrieved and to put out the results of anything that's non-trivial. We'll always put out the results in a data frame unless it's something like a visualization. So Pandas allows you to extend it, so you can write your own methods that will be like sub-functions of a data frame. So we've done that with a bunch of MSTICPy functionality. We have a few accessors, but we've tried to focus on two main ones. There's the MP accessor and an MP plot accessor, and we'll see when we use it what that looks like. So the MP one is things that are to do with data transformation or data analysis, and the MP plot one has all of the plotting functions. So let's read in a data frame. Here we're just reading it from a GitHub location, and this is what the data frame looks like, or at least the first 3 lines of it. So when we have the data frame, we can tab to the different functions. So MP, and it's showing you all the different functions we can do to operate on that data frame. So let's show an example. Here we're doing MP IRC extract, and we're looking for IP addresses or URLs on the command line. And here we found a few. There's some false positives, but there's. See if I found any IP addresses. A few there down there, right? Another example is visualizations. Again, something else you don't need to worry about import something from somewhere. The idea is you can just, if you have a data frame, you can plot relevant data in there. So this is one of our most popular ones. We've seen that already, the event timeline. You can get help on any of these accessor functions just by using the Python built-in help. I won't go through all of that because it supports a lot of parameters, and I don't want to talk about all of those. But it's just to see an example. So we're taking our original data frame. We want to plot a timeline. We want to tell it to group by the username, subject username, and we're going to include the command line in the pop-up help for each event. So it's as simple as that, to produce some kind of nice, well, we hope it's nice, but some kind of usable visualization. Because this is process data that we've read in, we can also plot a process tree from the same data. We can navigate around these, see if there's anything particularly kind of suspicious, where we can see Windows calculator there. I mean, I just picked this at random. I don't really know this data set very well. It's kind of quite odd that calc is faulting. That might be an indication that somebody's trying to do something odd with it, or maybe it isn't actually Windows calculator after all. Anyway, I don't want to examine the data frame or the data in there. I just wanted to show you how easy it is to plot and to process data from data frames using these Pandas accessors. So the second area, so Pandas accessors are really useful. We have a block of data that you want to do something to or visualize. You're taking like many rows. In many cases, operations are kind of focused around a particular entity type. So something like a host or an account or an IP address or a collection of those entity types. So another thing we've done, and probably like it was a year and a half, maybe more ago, we started building things called pivot functions. And these are shortcut methods to functionality in MSTICPy that are grouped around individual entities. So anything you might want to do with the host is attached as a method to the host entity. Same thing with account and with IP address. So we've gradually improved this over time. One of the big improvements we made in version 2 was to be able to use it more effectively with multiple data providers, query providers. So if you have multiple Sentinel workspaces, or you had Sentinel workspaces and MDE, in the past they would kind of conflict with each other. You could only really use them with a single, you could only use them one at a time. So we've now made it so that you can use it with multiple providers, and that you don't need to think about that too much, really. So as soon as you connect a query provider, then any pivotable functions, any functions that relate to like a host, and by relate to host, I mean they use host as an input parameter. So get all of the processes on a host, or get all of the logons on a host. All of those will appear to be now pivot functions on the host entity. And these are all added for each provider every time you connect, and we'll see that happening in a moment. So having just brought in our, we haven't really created any query providers yet, at least apart from that simple one with local data store at the beginning. So this is browsing the different methods that are available for pivots for different entities. So these are for DNS, like for domains, the kind of things that you could do. There's a few more for IP address, rather fewer for process, of a host, etc. You get the idea of this, and for each of these, there's like help that describe what the function is and how to use it. So if we load and connect a query provider, here we're, oh, I should have perhaps authenticated to this before I started, especially since my machine, oh, no, seems to be okay. My machine reinstalled updates overnight and was freshly rebooted, even though I'd prepared all the demo the night before. It was freshly rebooted for me this morning. So now we've connected to a Sentinel provider and we've connected to a specific workspace. If we look again at the pivot functions, we'll now see we have a whole bunch more functions. So connected to account, we've got Sentinel functions for AAD sign-ins of that account, syslogons. We look at host, we have the same thing. So we still have those original like risk IQ and virus total. Actually, there's no virus total in there, but IP address, risk IQ, virus total, geolocation function that we saw a little bit earlier, and the whois function. And you use these. I was just going to share an example. Although you can browse them, you can also do tab completion. Browse to a particular thing, and then you need to give it the host. I'm not going to run this here because I'm not sure what data is at the end of it, but for host names, my host. Anyway, that's the way you would use it. Very similar to a function, but here all the functions relating to host, as I say, are grouped to their according entity. And this is an actual function, which is very like the thing I was writing. We can see it returns the results, and this is from a live query rather than local data, which I showed you earlier. Final thing, we load another provider, this case Microsoft Defender, and browse. We can now see we've added Defender queries to our pivots. So our goal in both of these is once you've initialized MSTICPy, most functionality is available to you as a single line of code. So you don't have to worry about imports. You can just do something, get on with an operation, get on with the next thing. I think I've talked a little bit too long. My apologies to Pete. I'll let him take over. Pivot settings, that's just for backward compatibility. And next we'll look at some of the features.
Thanks, Ian. Let me just share my screen. So I guess a quick reminder, I'm Pete. I work with Ian at the Microsoft Sentinel Center on MSTICPy as well. So you've heard a lot about the changes we've made in 2.0 to make features of MSTICPy easier to discover and easier to use. And that's really a theme that we're continuing with these other features. And we've tried to focus on some of our most popular and most requested features in order to make them kind of more accessible. So one of those is our time series analysis features. So if you're not aware, time series analysis is basically just the process of taking a data set with a time element and looking for anomalies in the data across that time range. So a common example, and one we'll look at in a sec, is network traffic over time. If we look at the, say, total volume of traffic, can we see any patterns in that traffic over time, maybe spikes during the week and depths or low points during the weekend? And then do we see any anomalous points outside of the normal expected trend? And previously, to use our time series features in MSTICPy, we needed a little bit of code. It wasn't loads, but you can see here an example of kind of what was required, and we had to do some formatting of our data. We then had to do the time series analysis and find the anomalies, and then we had to plot it all out. So what we've done is simplified that right down. So now all we need to do is, once we have our data, is call our accessor np time series, analyze, pass it the elements we want to look at. So where our time element of our data set is stored in the time column, and where the data set we want to analyze, in this case, bytes sent in network traffic. And then we can just pass it to the np time series accessor and the plot feature. So we can do the analysis and the plotting all in one line. So if we run that, we get our time series analysis. Now the output is the same as we've had previously, but as you can see, we're taking what was quite a few lines of code down to 3 effectively here. Obviously, there's a few more with our formatting, but it's effectively 3 lines of code. So much quicker and easier way for people to access this feature. And it's something that is really valuable to apply to a lot of data sets. So we want this to be the sort of thing that you can easily apply again and again to multiple data sets with minimal effort. As well as ease of access, speed is something we've been looking at. Typically with Jupyter notebooks, people are working with very large amounts of data, and particularly with Sentinel's recent integrations with Azure Synapse, the ability to work with even larger data sets has become simpler and easier. And one of the areas we were finding a bottleneck in our process flows using notebooks and MSTICPy was things where we had to make external network connections. So threat intelligence lookups is probably the most obvious one here. Quite often we would want to do lookups of IP addresses against a large number of IPs, perhaps ranging into the thousands. And it's a slow process to query them, particularly when we're trying to do it against multiple providers. So one of the things we implemented in version 2 is the ability to asynchronously query providers, so that where we've got multiple threat intelligence providers, we're not having to wait for one to complete before we start the next. We run them all at the same time. This vastly improves the speed of the lookups, particularly when we're doing large volumes. But we've also added in just a simple display bar so that you can actually track the progress and you're not just kind of waiting and hoping the code is running as expected. So we'll do quick lookup, just these IPs here. You can see we've got our progress bar, and you can see we've only got 4 IPs, but we're doing 16 lookups because this is split over so many providers. And again, the results come back in the same format as we've had previously. Here we've got a data frame, but you can see that we queried Grey Noise, Alien Vault OTX, Virus Total, and IBM's X-Force, all in a relatively short space of time. Now, obviously, when we're just looking at 4 items, the time difference in terms of performing the lookup previously and now might not be super obvious, but when we're talking about hundreds or thousands of lookups, this is really a kind of significant game changer in terms of the amount of time you need to spend doing these lookups. However, it's not all just improvements in performance and accessibility in this 2.0 release. We do have some cool new features as well. One of them is our ability to graph data. So plotting the relationship between events on a host or within a network is super valuable for security investigations. And previously in MSTICPy, we've had a number of these graphing solutions for very specific situations. So we had one for instance, where we could see an incident, its associated alerts and associated entities. However, we wanted to be able to expand that out so that we had a much broader range of capabilities. So effectively, we could graph pretty much anything we wanted, as long as we knew what the connections were. And so using NetworkX and the Bokeh library, we've created a feature whereby we can call on a data frame, again using accessor, MP to graph, tell it where our source and target columns are, so the effectively how we want to create the links between them, and the attributes we want to use for it. So from that, we create a graph, and then we can simply either using NetworkX show that graph in a static plot, so you can see the links, or more usefully, call the MP plot accessor with network and get a interactive Bokeh representation of the same data set. So you can see it looks the same as the NetworkX one we had here. But by using Bokeh, we've got the advantages of doing things like zooming. We can hover over items to see more data. We can zoom in and out and get much more granular detail than obviously we can with a static graph. So again, here we're talking about a relatively simple and easy way of plotting out this data very quickly so that we can have a nice iterative process for analysts. Look at the data, change it up, run it again. And really, that's one of the things we're trying to drive with MSTICPy, like the minimal amount of code and the minimal amount of effort required to access that code. Now, previously, as with the time series analysis, one of our most popular features, the ability to plot maps and points on a map with Folium, has been quite hard to access. So even more so than the time series analysis we looked at earlier, the code required for plotting a set of IPs on a map was quite extensive. We needed to do a bunch of things with the data, including formatting IP addresses into IP entities, setting various parameters about how we wanted to plot a graph, formatting our data into various groups based off of different elements in the data set, and then finally displaying a graph. So you can see this is quite a lot of code and quite a lot of effort to go through really to do something that should be relatively straightforward. So again, we vastly simplified this. If we get some data, we can see we've got a nice data set here. We can see some external IPs, which we're seeing network traffic from. And we have a latitude and longitude in the data set for them. And from here, from this data frame, we've got two easy ways of plotting it. So we can call mpplot, and this time Folium map, and simply pass it the IP address column. So we can say we've got IP addresses in this column, go away and geolocate those IP addresses and plot them on a map. And here we go. Nice plot. We can see all of those IPs located across the US and Europe. And we can do all the things we could previously do with Folium. We can zoom in and hover over and do all of those good things. We can also call the same mpplot Folium map feature, but this time just tell it that, look, we already have latitude and longitude in that graph. So here are the columns. And again, we have the same graph, nice and zoomed in this time, but if we zoom out, you'll see it's the same plots as we had previously across Europe and the US, but this time we're just using those different columns to plot the location, given that we already have them in our data set. We've also extended the Folium map feature with a bunch of new elements to allow you to further customize the map. Folium has a lot of capabilities around what plots to see and having various layers to allow you to easily filter data in and out when you've got a large number of points on the map. And we've made these things easier to access in MSTICPy. So here we're taking our data frame that we had previously, geoloc.df, and we're adding in a bunch of other elements related to friendliness, flavor. I'm not quite sure what the flavor of a location is or an IP address, but we're adding this all into our data frame. So we've now got all of these extra attributes. Apparently, Toronto is not friendly and tastes like cinnamon, which I'm not sure is entirely true, but I've never been to Toronto, so maybe it is. But now we've got these extra elements, we can again call mpplot Folium map. This time we can add some extra parameters. So we're going to say we want different layers in our map based on the country name. And we want to have some tooltips. So these are hover over pop-ups that we'll see on the map of status and flavor. And then we want to have what we call pop-up columns, which are things we can click on a point and see based on some of the other attributes we just added. If we run this, see, so similar map to before, different colors this time. And that's because we have these different layers on that map. And we can select and reselect these to see that data. So let's say we're just interested in Canada this time, and we can zoom in and look at Toronto. We hover over and we can see those status. And we can click and see those pop-up elements we talked about previously. So a nice, easy way of adding a whole bunch more data and customizability to our maps with just a few extra parameters to that Folium map Pandas accessor. We can also do some more customization based on points. In this case, we're creating an icon map, which based on the country is telling us use this color for the icon plot and then have a little different icon. So for the US, we want green and a flash icon. For the UK or Great Britain, we want purple and a flash icon. And for everyone else, we'll just have the default blue. And again, we can pass this in as an icon map parameter to Folium map. And you'll see here, we've got exactly that. Our US points are green with a flash icon. Great Britain is purple, and everything else is blue. And obviously, all of these elements can be combined. So we can have layers, we can have colors, we can have different icons, we can have different pop-ups. Really, it just gives you a lot more flexibility and customizability in what you want to do with the maps, which is really great for helping make them useful in an investigation where you have loads of different data points and you need to kind of differentiate or drill into them a bit more. One of the other things we've added, which is more of a administrative piece, is we've improved our workspace configuration for Azure Sentinel or Microsoft Sentinel, sorry. So previously in our config editor, you had elements that allowed you to specify things like workspace ID and tenant ID, which are needed for connecting to log analytics. But you can also specify things like resource group, subscription ID, and workspace name, which are needed by some of our integrations with the Sentinel API. So to make it easier to set this config correctly, what we've done is added features to just resolve these remaining settings. So when we've got this this gap, like resource group hasn't populated, well, we can work them out based on tenant ID and workspace ID. So just by hitting resolve settings and waiting a second, what we should get is this populate out. There we go, great. So from just having workspace ID and tenant ID, it's worked out our subscription ID, resource group, and workspace name for us. So a pretty minimal thing, but something that will just make configuring your workspace easier. This is particularly true if previously you only had workspace ID or tenant ID included in your config file, which was what we initially only supported. So rather than having to go manually look this up, you can just go through the GUI and the widget and just resolve all the settings to populate everything else for you. Now, finally, we want to talk a bit more about the project reorganization. So Ian mentioned earlier that we've kind of reorged MSTICPy to make it a bit easier to A, use, but also B, maintain, particularly going forward. And so one of the things we've tried to do here is think about the contents of the package a bit more logically. Previously, we had a few main top-level folders, which contained pretty much everything. However, those folders no longer really represented large amounts of what was in them, just because they were conceived when the package was very young, and we've added loads more features and kind of expanded its scope much more since then. So our new structure adds many more top-level folders, but it allows us to be a lot more extensible in future, but also a lot easier for us to maintain and a lot easier for people to find features because it's much more logical where things sit now. So we have folders like analysis, like data, like widgets, like viz, which all contain kind of features for interacting with the data like you would expect. So things like data involves collecting data, analysis is things like our time series, and viz is things like our visualizations, many of which we've seen here. And then beyond that, we've got things that are a bit more related to administration of the package and configuration. So things like auth to handle the various authentication methods we have, config for setting the config for MSTICPy, common contains things like exceptions, which come into the whole package. So effectively a lot of administrative things. So what does this mean for a user? Well, really not a lot. If you're doing direct imports of specific features, you'll have to remember where they are, or you have to find the new locations. But at this point in time, we've added stub imports to allow you to use old import locations without any issue. We will be removing this in the future, but that's not in the current release. But I would recommend, if you're a regular MSTICPy user, just having a look at the new structure and kind of familiarizing yourself where things fit. I think from our side, it all seems relatively logical and straightforward now, certainly much more so than it did. So hopefully you'll find the same. Another important point is that with the release of 2.0, we've decided we're officially dropping support for Python 3.6. Python 3.6 has been end of life for a while now, but it's still widely used, or was still widely used within the community and our user base. So we always maintained support for it. However, given that support or usage of 3.6 has dropped off a lot, and it's been end of life now for quite a while, we're officially dropping support for it. That's not to say MSTICPy won't work. It's just that we're no longer actively working to ensure compatibility. So if you are still using Python 3.6 in your notebook environments, we'd strongly recommend you start moving away to at least 3.7, preferably 3.8, 3.10. And I would expect to see breaking changes to MSTICPy 4.3.6 in the very near future if they're not already there. Now we realize we've covered a lot of things today, and if you're completely new to MSTICPy, some of this may have been kind of a lot of information to absorb, but we have loads of documentation and support and guides out there for you. So we'll stick these in the Q&A for people to see, but I'd strongly recommend checking out our documentation. We've added a new getting started guide into the MSTICPy Read the Docs, which is really good, particularly when combined with the getting started notebooks we have for Sentinel. And also keep an eye on our blog and our MSTICPy Twitter account to kind of keep up to date with all of the new features we're adding, links to useful blogs and resources, and it's also a good way of engaging with us. On top of that, GitHub is, as always, the place to engage with MSTICPy, whether it be issues, feature requests, or contributions of code. Everything is welcome. We also have started using discussions quite heavily on GitHub. So for the 2.0 release and the 2.0 planning, we had a discussion about things like structure of the package and what we wanted to see. And we're going to continue having these for future plans and releases. So again, if you want to be engaged, that's a great way of seeing what we're doing and contributing your input to it. We're always keen to hear input from our user base, and really the future direction of the package is going to be driven by those contributions from our users. So thank you very much. I don't know if we have any questions, but I'm sure Jason will let us know if we've missed anything in the chat.
Yeah, thanks, Pete. It seems like all the questions were answered in the chat. So I'd like to thank Pete and Ian for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you, and see you next time. Goodbye.